Good morning, friends. In this video, we are going to discuss about introduction to microservices. So let us start with monolithic application. So what do you mean by monolithic application? It's like a single web application which contains the entire business activities, all the business services, and it is developed and managed by a single team. So that is called monolithic application, right? So what would be the challenging with monolithic application? So if the more and more traffic comes to the application, and when we want to introduce more and more features, because more clients are getting added, obviously we come up with new functionality, right? In that case, the application becomes complex and there would be number of developer teams will be added to develop this application, right? So this is where the manageability application becomes very difficult, right? It becomes like big ball of mud, right? So this is where we need to look for some alternative. As part of agile development, agile best practices says, to achieve continuous delivery, so instead of working with the larger teams, let smaller teams work on individual modules, right? So this is where if you see the microservice comes to picture, okay? So if you look at what is microservice architecture in a nutshell, it's a single responsibility principle. So what is this principle says? It states that gather together those things that change for the same reason and separate those things that change for different reason, right? For example, instead of larger teams working on single application, when we want to develop different modules, but how do you identify those modules, right? So this is where the single responsibility principle comes to the picture. For example, you take a module that compiles and prints a report, right? So there is a compiling the content as well as print the report, right? So imagine such a module can be changed for two reasons. One is the first could be the content of the report could change. Second one is the format of the report could change. So this is where we need to develop this with two modules, right? So if you look at this diagram, like from the monolithic, complex monolithic application, when you want to make it as modular approaches, there would be different teams working on different independent modules, right? So that is how we can achieve it, right? So what is exactly microservice architecture? According to Martin Fowler, a microservice architecture consists of set of independently deployable services organized around business capability, automated deployment, intelligence in the endpoints, and decentralized control of language and data, right? So the services must be independently deployable, and we should implement automation, right? End-to-end automation. For example, as a developer, you commit some code, automatically that application should be pushed into the production environment, like continuous delivery can be achieved, right? Similarly, the intelligence in the endpoints also, because one service is talking to another service. So those endpoints may be dynamically changed. At the same time, the caller should be intelligent enough to make the call to those endpoints, right? So these are all the main concepts of microservice architecture. And if you look at one more definition of microservices, the microservice architecture is a method of developing software applications as a suite of independently deployable, smaller. Each service runs a unique process and communicate through a well-defined, lightweight mechanism to serve a business goal, right? So if you look at this diagram here, there are different services like account service, inventory service, shipping service, there are different services. Assume that these services are developed using Spring Boot. When it comes to Java, mostly the web services are developed using Spring Boot, right? Because one of the advantages of Spring Boot is Spring Boot comes with an embedded Tomcat. So it is very quickly we can launch the application. Similarly, we can do graceful shutdown, right? It's very lightweight. So here, like as per the definition, each service like can be independently deployable because it is running as a separate Spring Boot applications, right? And they are small in the code base. Similarly, each service runs a unique Java process, right? Each unique process. For example, when you run three services and when you check for JPS, Java process, automatically we will see three processes because each is running as a separate process, right? Similarly, communicate through a well-defined lightweight mechanism to serve a business code. Here, the lightweight mechanism is nothing but REST you can see here. For example, each service exposes REST API so that other service through REST API make a call to those services. Like, REST is lightweight because REST is just a pattern, right? REST runs on top of HTTP. HTTP is once again a stateless protocol. It is a lightweight protocol, right? Similarly, if you look at this diagram where you have multiple microservices, we can have API gateway as the beginning so that it is like you can say API gateway is almost like a facade kind of pattern actually. Gateway itself is a pattern, API gateway itself is a pattern. But if you look at gang of 4 patterns, it is like a facade pattern, right? So any request comes to gateway, from the gateway it makes a calls to the services, right? Similarly, if you look at here, there is a mobile application. Similarly, there is a web application, right? So in the case of web application, there could be storefront web app, which is an application maybe developed using so any kind of AngularJS or anything. So that application talks to the microservices, or there could be API gateway, which is exposed to the mobile kind of applications, right? So this is how we can develop microservices to achieve continuous delivery and highly resilient applications, right? Then how do you identify these microservices? We discussed about single responsibility principle, right? So that is a principle which is really helpful to identify the modules. But when you are developing microservice architecture, we have domain-driven design patterns, right? So, like Eric Evans, he identified some patterns and wrote one book on domain-driven design patterns also, where these patterns are classified into, there's a strategic patterns, similarly there's a tactical patterns. These patterns really help us to identify the microservices and build microservice architecture, right? So similarly, when you're identifying the microservices, initially it starts with analyzing the domain first, like which domain we are working actually. We need to analyze the domain. Similarly, define the bounded context. So to define the bounded context, very important thing is we need to identify the entities, aggregates, and services, right? These are all part of tactical patterns, right? Based on that, we can identify the microservices. So if you look at this diagram here, so these are all like bounded context, right? Inside the bounded context, there are different microservices. But how do I identify this bounded context is one thing very challenging, right? To identify that, so we need to work on the entities, aggregates, and services, right? So what is bounded context is all about? Bounded context tries to define boundaries of our complex domain into business context, right? For example, there's a sales context. Similarly, there is a shipping context, right? Or there could be some payment context. So bounded contexts are important because they allow us to define an ubiquitous language that is shared and valid within a boundary. For example, in the sales context, what language we talk, what ubiquitous language we talk. So that is different from a payment context or order context or something, right? So this ubiquitous language is a model that acts as a universal language to help communication between software developers and domain experts. So this is very important actually, the bounded context. To identify the bounded context, first we have to derive the model, right? In the model, we need to first identify the entities, aggregates, and services. Then it becomes easy to identify individual microservices. However, our scope is just limited to going through microservice concepts and understanding the ecosystem rather than spending more time on domain-driven design pattern. But in the subsequent videos, you will have more information about domain-driven design pattern, right? So when it comes to microservice, what are the benefits of microservices, right? It's a smaller code base because we'll identify, each module will be like running as a separate microservice. Easy to scale as an individual component. For example, if there is a payment service which is getting more number of requests, we can increase number of instances for the payment service. When it comes to monolithic application, the entire application we are going to have scalability. But here, individual service can be auto-scaled or manually we can scale it, right? Similarly, technology diversity. That is, we can mix libraries, database frameworks. For example, one microservice can be developed using .NET, okay, maybe using MongoDB kind of database. Maybe another microservice developed using Java with a relational database. So as long as these services communicate using some common protocol, for example, they communicate using HTTP like a REST kind of pattern, so they can interact, right? Fault isolation, that is a process failure, should not bring whole system down. Even if one service is down also, that should not impact the entire domain, right? As these services are running independently, even if one service is down also, we can have some kind of patterns we can implement like circuit breaker patterns. So using those patterns, so what we can do is, we can have some fallback mechanism, right? So better support for smaller and parallel team is very important because there are independent components. Actually, it is easy to manage and independently deployable. Similarly, deployment time also will be reduced because you compare with a monolithic application. Here we are running as individual modules. Each module, so overall the size would be very less, even if you want to push between different environments also. So the deployment becomes very fast, right? And there are some challenges of microservices, but for all the challenges, we have some tools to address. For example, difficult to achieve strong consistency across the services. So this is where we have to implement some kind of governance, maybe at a design time governance and runtime governance. Similarly, ACID transaction do not span multiple processes because when it comes to distributed transaction, like In Java, we use JTA, Java Transaction API. So it is not recommended to implement JTA kind of transaction for microservices, right? Because each microservice will be running as independent services. So this is where we can look for some patterns like Saga is one of the design patterns. So we can implement Saga patterns using choreography or orchestration kind of stuff, right? Similarly, distributed systems so hard to debug and trace the issues, right? Because there are some hundreds of microservices, and if you want to know how much time the latency, for example, we want to identify the latency problems, or we want to know how much time it took to execute the entire transaction, there are some tools like, for example, Jipkin is one tool we can be used as a tracing tool. Similarly, we can use for logging purpose, we can use ELK, Elasticsearch, Logstash, Kibana, or we can use Splunk with Logstash, Splunk with Kafka kind of environment, right? And greater need for end-to-end testing. Today, most of the testing tools, for example, JUnit, Selenium, all these tools provides even integration support also, right? Required cultural changes in across teams like developer and operation working together even in the same time, same team, right? So this is where the developer and operation team work. Till now, we are used to work independently, right? With the help of the microservices to achieve continuous delivery as part of cloud native application. As part of cloud native application, there are 4 characteristics. So one is DevOps, second one is continuous delivery, third one is microservices, fourth one is containerization, containers, right? So this is where in the organization level, there will be some cultural changes where developer and operation team work together to achieve, to provide value addition to the client, right? To achieve continuous delivery, right? So if you want to build microservice architecture, so there is a complete ecosystem if you see. So for example, if you observe here statistic service, account service, notification services, these are all microservices, right? Developed using Spring Boot kind of technology. So on top of this, there is a API gateway, right? Because we discussed these services should not be directly exposed to the client. So here when I say client could be a third-party client is trying to access the services, or the client could be UI. For example, we can have AngularJS kind of UI environment. That UI will expose the services to the end client, right? To the customer, right? So that UI, like client, can talk to API gateway. So API gateway is the starting point here. We have different tools like Spring Cloud Gateway. Similarly, we can use FPG. There is a 3-scale, even WSO2. There are different API gateways are available actually. So advantage of this is, instead of exposing all these microservices to the application, to the client or UI, we can have a single contact like API gateway. So the UI will make request to API gateway with some kind of URL, then API gateway will talk to the services, right? Similarly, these services must register to one service discovery or service registry like Eureka. This is very important. So instead of hard coding IP address inside the services, for example, if the statistic service to call account service, we should not hard code the IP address of account service inside the statistic service. That is not recommended, because if the account service IP address is changed or more number of instances of account service is started, we need to modify the statistic service, right? So as per the OCP principle, open close principle, we should follow the close for modification, open for extensions, right? So instead of writing hard coding the IP addresses, let these services register to Eureka, like service discovery, or we can use Apache Zookeeper console kind of registries, right? It is almost like in an enterprise application, Java enterprise application, we use JNDA. So Java naming directory interface. So what is the purpose of that? So that is where the data sources, EJBs, queues or topics will get registered, right? So that the application requires data source. Inside the application, we need not hard code the data source configuration. That application look up to JND and get the data source, right? So similar to that in microservice architecture, let each and every service registered to service discovery with some unique name followed by the IP addresses. And the services internally, they use the name, service name instead of using the IP addresses. Similarly, we can implement Spring Cloud Load Balancer. This is the client-side load balancing. For example, if statistic service to call account service, if there are a number of instances of account service, at a statistic service level, we can do some load balancing for account service, right? It's a client-side load balancing. In a typical web application, we go for server-side load balancing, right? So like F5, some hardware load balance like F5 or Apache HTTP server, IIS server, we used to have it, right? So that is like for the complete ecosystems, right? So even here in this complete microservice ecosystem also, we can have starting point like F5 as a hardware load balancer. So that from there it can come to API gateways, right? But this is like client-side load balancing. Client-side in the sense microservice level, right? One microservice to talk to other microservices, there would be some load balance actually. Similarly, there is a resilience 4J. Here, resilience 4J is nothing but circuit breaker pattern. The purpose of this is when the statistic service is calling account service, if account service is not responding, right, then in the resilience 4J circuit breaker pattern, we can implement some kind of fallback mechanism. Otherwise, what will happen is when the service is calling, one service is calling another service, that service is calling one more service, and the final service is not responding, it will badly impact the latency of the other services, right? So this is where we can have a resilience 4J circuit breaker pattern. Similarly, there could be other patterns also we can implement. For example, if you want to have a retrieve pattern, we can implement bulk head pattern. There are different patterns available. They're all part of resilience 4J. We can implement it, right? Similarly, these services, so they can have application-specific property files into some GitHub, and we can use a config service which will talk to GitHub, right? So advantage of this is all the application properties, microservice properties will be in one location. If any changes are done to those property files, we need not to restart the services. We can refresh using some tool called actuator. So we are going to see each pattern actually independently in modules, in different modules. With a different videos, we will see it, okay? Similarly, to implement the single sign-on or security among all the services, we have a OAuth service actually, right? For example, at a gateway level, we are going to configure where is the OAuth server, all the configurations, so that these services are secured. These services we will secure swing security, and says we will mention to invoke a service, it requires a JWT token kind of stuff, so that when the client application is making a call to gateway, gateway will first redirect the request to authorization server. Authentication will happen, then the token will come. With the help of token, API gateway can talk to the services, right? So that is what we can implement. Similarly, all these services can send logs to one centralized location like ELK, or we can use Splunk with Kafka for log analysis, right? What is the advantage of this? Instead of generating the logs at individual service levels, we can have a common place where we can put all the logs, right? So we use ELK, Elasticsearch, Logstash, Kibana. Kibana is one UI. From there we can see, we can search for the logs also, right? Similarly, when you are using some resilience 4J, maybe circuit breaker, other things, other stuff. So what we can do is we can connect those, because the circuit breaker, it is going to evict some metrics, right? For example, circuit breaker is closed or open, how many requests are success or failure. That information can be passed in the form of streams to, there is a micrometer, through micrometer Prometheus, we can monitor the complete metrics, right? So that is one tool which we can integrate it actually. Using this Prometheus, we can say at any point of time whether the circuit breaker is in open state, closed state, how many requests are successful, how many requests are failed, all those information we can get it. Similarly, to implement the latency, for example, tracing, end-to-end tracing. Suppose from the AngularJS request comes to gateway, from the gateway, especially from the gateway to the statistic service, our gateway will invoke service discovery, get the endpoint of statistic service, make a call to this, and this service is talking to config service, example. So if you want to know end-to-end latency, how much time it took for the end-to-end tracing information, we can use a tool called Zipkin. So Zipkin is mainly used for distributed tracing. Advantage of Zipkin is we can understand exactly at which particular service the latency is more, so that we can tweak that application, right? We can improve the performance by tweaking that application. So similarly, so we can implement different tools like Grafana, Alert Manager, the different tools to have the distributed environment. Because it's a distributed environment, these tools will help us to have some centralized information, right? Similarly, when it comes to microservices, the different patterns are available in the microservices. Like for example, API gateway, service registry. So API gateway is nothing but, here we discuss about API gateway like Spring Cloud Gateway, APG, there are a few things I told you, right? This is the starting point for the ecosystems. Similarly, we can develop service registry. We can use a pattern like service registry, like Eureka. Similarly, we can use circuit breaker as part of resilience 4J. We can use circuit breaker. Similarly, we have messaging, database per service, access token, Saga, event sourcing, CQRS, command query responsibility segregation. There are different microservice patterns are there. So pattern is one thing, best practice, we need to implement it, right? So we're going to discuss about each and every pattern in the subsequent videos, right? So the next video, we are going to discuss about service discovery, registration registry pattern using Netflix Eureka component. Thank you so much for watching this video.